So, as almost said, I didn't know I was going to do this until a couple of days ago. So I didn't have a chance to prepare a formal presentation with slides and all that. So we're going to do it Bill O'Reilly style. We're going to do it live. So this is the third third course in a series whose purpose it is to prepare you guys to participate in a hackathon. The first one we talked about Git and showed you guys how to create, how to branch, how to clone so that you can collaborate with each other. And the second one we talked about RESTful APIs and how to communicate with websites and set up a small website so that you can look at it from the server side's perspective. What we're going to do today is we're going to talk about Python and some data formats that are fairly common, and try to get you guys to get some hands-on experience if possible on this. So let me ask you if you guys are already familiar with Git, if you participated in that course and you understand that. All right. Then second, did you guys participate in the RESTful API presentation? All right, good. We have some people who are following along. So now let me ask you this. Do you guys have any experience with Python? Raise your hand if you have. A little bit. Raise your hand if you have Python installed on your machines and are able to follow along with the examples.
Yeah, if you guys were here last time, you have Python installed.
Good. Then the next thing, and this I don't expect much positive response, but have you guys worked with Eclipse? Has anyone worked? Oh, excellent. Do you have it installed?
Yes.
Better still. All right. So that's going to help a lot. For those of you who do not have Eclipse, it is available online. You can download it and it's free of charge. You can go to Eclipse and you're looking for the Luna package, which is the most recent version of Eclipse that's available. I do have a USB key here with a copy of.
I can go around and help people install.
Right, but the one that I have is just for Mac.
Okay.
If they have something, if they're on a Windows PC, because this is specific to the operating system you're running on, you would actually have to download it from this particular website.
Looks like majority are PC.
All right. If you want to try downloading it, go ahead. If you already have Eclipse, that's even better. And then the next thing that we're going to use is something called PyDev. PyDev is a plugin for Eclipse that allows you to do Python development in Eclipse. And it has some very nice features that make it a lot easier to work with Python. For one thing, it has a debugger so that you can step through the code and you can examine variables and their content as you go along. So it becomes very, very important as you develop in Python and you get into more and more complex programs to be able to do that. There's this website. You can go to pydev.org and it will show you the instructions on how to install PyDev. It's more than one step to get there, but it's fairly detailed instruction with graphics that show you step by step what it is that you need to do to install it and to hook it in. I already have Eclipse installed in my environment, and I already have PyDev installed. So you see this icon on the upper right hand side that shows you that that PyDev is installed. So having said that, so what are we going to do? We're going to talk about a few of the formats, the three most common formats, two of them at least, and if we have time, we'll go into the third. And these are XML, HTML, and those are basically, one is a derivative of the other one. And then the other format that we're going to talk about is called JSON, and it stands for JavaScript Object Notation, and it's a way to store data or JavaScript objects, download them into a format that can then be reloaded. Python has its own format that's very similar to JSON that they use to store Python objects, and that one is called Pickle, and we're going to be using some of that. To put together an example that would use some of these formats, what I did is I created this small little program called Macallan HTML .py. This is a Python program, and we're going to go through it, and it will illustrate some of the formats that we're going to be dealing with. We're going to use something called a package called request to go to the Macallan Chamber of Commerce page, and we're going to pull that main page down. And then we are going to use a program that I developed, and this one I do want Alma to share. It's in this USB key. It's called HTML tree.
Actually, could you add it to like a Git page? Maybe the source code that you have as well? Like a GitHub?
I could eventually, but I don't want to do it right now.
Sure. I'll start sharing it.
All right. And I'm going to talk about that particular program because it's a fairly small program, but it depends on a library called the HTML parser. This library is available for Python, and you can download it from the web. Let me show you how you do that. This is how you install it. You run the command pip install HTML.
Could you make that a little larger?
Sure.
Command plus, yeah.
And plus. Can everybody see it now?
Maybe move the window up a little.
1 second. There we go. So it's simple pip install. I've already done it myself, so it should, if I repeat it, it's idempotent. It means that it won't cause any problems if you run it twice. And it tells me that it's already there and everything's fine. I'm running Python version 2.7, so it installed it in the site packages library. What this HTML parser does is it is able to read HTML HTML files and decode them token by token, but then it doesn't know what to do with the tokens once it has them. So what you do is you create another program on top of the HTML parser that has the functions that are going to operate on the data that the parser or the tokens that the parser is detecting. So you create things. So here's my tree builder, which is the class, the Python class that I created. And you can see that it inherits from the HTML parser. And what it does is it adds some functions to it. One is to feed the data in, and then a function to handle the starting tag, a function to handle the start end tag, and one to handle the end tag. So what the parser itself, and then one to handle the data, of course. So what the parser is going to do is I'm going to feed it the data in, and it's going to say, hey, I found a starting tag. And it gives me the tag and says, here's the data, what do you want to do with it? And here's an end tag, and here's a start end tag, and so on and so forth. At the end of this, what it will do is it will read an HTML file, whatever file you feed it, and it will convert it into a hierarchical structure inside Python that you can then operate on. So what we're going to do with it is something fairly straightforward. We're going to start with an HTML file, feed it into this Python structure, and then we're going to use another library that can take that structure and convert it into a Python pickle structure. And then we're going to take that pickle structure and we're going to convert it into JSON and spit it back out. So this allows you, this is a data transformation that we're going to perform on something that we pulled from the web. All right? And we're going to do this in debug. So this is where it becomes very convenient to have something like PyDev and Eclipse. What I'm going to do is I'm going to put a breakpoint on line 17 that says when you get to this point, stop, proceed no further. And I can run the program in debug, start the process in the background, and now we're at the point where we're going to send the request to get this particular web page. And F6 will execute that command single step. So it will execute one line of Python and then stop. So what happened there is we used this library to go out on the web. We hit this web page, and the result came back in this page. We can look at it in our variables. There's the object called page, and all of the information related to it, what the type of encoding it was, what type of connection we had. But what we're interested in is the text of it. And the text is the actual text of the web page that will be returned. If you're on the browser, if you were on a browser, you hit that page, this HTML would come back to the browser interprets it, and that's what you see as the web page. This is the web page that we're hitting, macallan.org contact chamber, and this is the information that it contains. We can look at this as source. We can view the source by just clicking on it and view page source. I have that page source here. So this is the HTML that's going to come back. HTML typically has these tags that have open angle bracket, close angle bracket that identifies them. That's a beginning tag, and an end tag has the same name but with a slash. So you'll have a HTML tag, that's the beginning tag, and a slash HTML tag, that's the end tag. And then for each beginning tag, there should be an end tag. And you can create a hierarchy of these tags. One special tag is this exclamation point dash dash. That makes it a comment. So this is, for all intents and purposes, ignored. And you have a style tag, and this is the end of the style. So all of this information is going to be in between those two structures. And then the body, and so on and so forth. So this is what the XML or the HTML looks like. And we've just loaded that HTML into this object called page. And now we're going to call the program the HTML tree program. And we're going to create an object called a tree builder. And this flag true says, give me some debug information as you start parsing this HTML. And the result is going to be stored in this other object called P. So I'm going to run it. And so there, it completed. So that just created the parser. Now I'm going to tell the parser to feed in that page, that HTML page. So when I execute this command, then what happened is that text, that HTML text, was passed on to the tree builder, and you'll see that there's some messages that appeared. So it says, warning, I found some extraneous end tag when I didn't expect one. And it tells me what line it's at and what offset it's at. So this is actually my program that's coming back with this warning because it received a tag when it didn't expect to see a tag. Now, to be perfectly honest, the reason why it's doing this is because there's a bug in my code. It's not 100% working, so it didn't know what to do. And I'll show you what it is that it got confused about. So it says it's at line 351. So if we go to line 351 of the HTML, you see there is an end tag, an end div tag. So my program is keeping track of what tags it saw at the beginning, and it expects for each beginning tag to see an end tag. But it got thrown a curve because it appears that there's two div tags coming in. But in reality, these two tags are one and the same. We're just being given the information in part A and part B. So we got a tag, a div tag that just tells us the ID of that division. And then later on, we got another div that tells us what the style of that tag was. So we got two of them. My program did not expect that. And when it got to line 351, it says, hey, oh, hang on. Yes. When it got to line 351, it says something's not checking here because I received two div tags coming in, and now what do I do with this other tag? So that's so it threw this error or this warning, and you're going to see several more warnings. But at the end of this, it's going to be able to partially read this HTML file. So you as a programmer, if you were parsing some HTML, what you would be doing is you would be writing a program similar to this HTML tree, and you would be writing specific instructions on what to do when you see specific types of tags coming in. All right? And at the end of it all, we managed to partially read this HTML, and it's now in this object. Now, this structure, this tree that was created, contains other Python objects in it. And the reason why that's significant is that if you were to try to take this structure directly and convert it into JSON, you would get an error. And you'd get an error that it's not a serializable structure. JSON is very limited in what it can do. So you can't take that structure and automatically generate JSON from it. But what we can do, and this is what I did here, is I'm going to encode it is a JSON pickle, which is a JSON-like structure that has some additional information that turns all of these objects into something that appears to be ordinary JSON text. So we're going to execute this line, and this, as you can see, takes a while. And now that we've done it, this JSON string, this object that, or what was originally this Python structure, has now been converted into a regular text string. And that's this one up here. But I don't like it. And the reason I don't like it is because the entire text is one run-on line. And it's very difficult to look at. So what I'm going to do is I'm going to turn right around. Now that I know that this is JSON, legitimate JSON, I'm going to reload that JSON using a JSON loads command. It says, take the string and reload it back into an object in Python that I'm calling JSON object. And the reason why I do that, excuse me, the reason why I do that is because once I have it back in as an object that doesn't contain other objects inside, it's a pure data structure, I can now tell JSON to print it out using pretty print. So now I take that, I use the JSON library and I dump out that object and I tell it to sort the keys alphabetically as it iterates through the structure and use an indentation of 1. Anytime it encounters hierarchical data, it'll just indent by 1. And it's going to use separators of commas and colons. So when I do this, what you're going to see is it now printed out that same data. Oops, excuse me. It's a JSON structure. So this is the same data. We started with a web page. We called it in. We got HTML. We passed it through an HTML parser, and then we converted it into JSON, and now we printed it out as this pretty print. It's pretty much a whirlwind tour of data transformation. So let me pause at this moment and give you an opportunity to ask questions about something that you might want me to delve into in more detail. Yes?
Just to be clear, you just summarized it right now, but you say you got the HTML and then turn it in not JSON specifically, but into Python-like?
JSON pickle.
JSON pickle?
Yes.
JSON pickle. And at that step, it was when you had the entire string by itself. the single line.
Yes.
And then from there you turn it into this, which is just JSON itself.
Yes. There's absolutely no difference between what you're seeing here and the line, other than that it's broken down with carriage returns and indentations, but it's exactly, when we obtained that string, at that point in time, we had legitimate JSON code that we could, or a JSON string. It's a data structure following the JSON conventions. What makes it a pickle is this additional data that Python embeds into the object itself. So anytime it's trying to put something out that is in a Python object, it puts out a marker that says this is a Py object and this is the module that you need in order to interpret this data. So there's some additional metadata that's embedded into that JSON file that makes it a pickle. If I were to directly try to go from the structure to JSON, as soon as an object was encountered, the JSON dumps function would say, this is not valid, this is not serializable, I don't know what to do with this. But by going through the pickling process, that library took that information and converted it into these metadata tags that I can now read this JSON back and recover the original Python structure I started with. Does that make sense? Okay.
For example, the HTML that you have for us, like it can be used as a template to do this process, or?
Yes. Yes, the program that I gave you, it gives you an idea of how to go about dealing with a parser. And most of the heavy lifting is already done for you by the HTML tree object. It knows how to read code and interpret the open angle brackets and the slashes and all of that. So it tokenizes that HTML and then gives it to you one token at a time. And then from there on, you decide what it is that you want to do with those tokens. Do you want to throw them away? Do you want to look for specific data? Are you looking for a particular path through that HTML for some specific data that you want? And so on and so forth.
So once we install the Eclipse and we install PyDev, the extension, the plugin, you want us to open the HTML tree Py, or what do you want us to do after we install both of these things?
Yes. Once you have Eclipse and once you have installed PyDev, well, actually, even before doing that, what I did here was to run the program in the Eclipse environment so that we could single step through the code. There's nothing to prevent us from running that same code from the command line. Let me illustrate that.
You set up the template by the yeah.
No.
Where did you get the template?
Excuse me.
Yes.
I'm electrical engineering. I'm not computer related. So, but you were saying that the implementation of this now JSON structure
Yes.
will be to search for specific notations within the HTML files.
Yes.
So, per se, if there's a hidden object within the structure of the website, you could pull it out doing this JSON search.
Yes. What HTML is a particular way to describe data that is hierarchical in nature. So HTML is a type of XML, the extended markup language. And the way the markup language works is by having these kinds of notations that you see here, like this. This is an HTML tag, division header. This is also a tag, this A. This is also a tag, B. And these are arbitrary names. You are creating, in that HTML, you're arbitrarily creating tags. And the rule for tags is that for every beginning tag, there must be an end tag. And then within that tag, you can create other tags inside and create a hierarchy, a tree. So for example, here inside of the body tag, there's a division tag, and then inside this division tag, that has an ID, and okay, so here's one tag, division ID equal wrapper, and here's another tag, division ID equal header, and so this header 2 is inside this wrapper tag. So you have a hierarchy. Outside you have the full wrapper, then you have the wrapper, and then you have the header 2, and then you have the style. And then inside it you have this tag B. Here's the beginning of the tag B, and here's the end of the tag B. So the HTML parser is, when you run through it, when it encounters this B tag, it's going to say, hey, I found a B tag, and here's the data associated with it. And it'll pass you along the string. And then it'll pass you another tag. When it encounters the /B, it'll come back and say, hey, I just discovered the end of that B tag, and here it is. So at that point in time, you know that you've received whatever the text was between the beginning B tag and the end B tag. Does that make sense? So that's what the HTML parser is doing, is saying, imagine if you were walking through all of the files in a directory. So you start with a directory and says, okay, I found a directory. All right, I found a subdirectory and it's called X, and within this X, I found another directory called Y. And then I now found this file, and this other file, and this file, and now I've finished with Y. So we're now with X, out and back at X, and oh, there's another directory Z. You see how you can traverse through this structure, and you can be nesting deeper and deeper into these levels and coming in and out until you finish walking through all of the directories and all of the files, and then you're done. Well, the parser is doing that, except that instead of walking through a set of directories, it's walking through a data structure that has these hierarchical properties. And what we've done is we've read this hierarchical structure, and then we wrote it out as a hierarchical structure using a different notation called JSON. This structure right here is also hierarchy, but instead of using those angle brackets, it uses these curly braces to define the beginning and the end of particular tags. So it says, I have attributes. One attribute is width, and that's it for attributes. Now I have data, and my data is blank. Now I have nodes, and it's an array, and inside that array, each one of these nodes has attributes, has data, and has other nodes. And that's also an array, and so on and so forth. So it's describing this hierarchical structure, the same data as we originally saw in HTML. Does that make any sense? All right. The reason why we would want to do these conversions is that when we're interacting with different applications, some of them expect the data to be in certain formats. So they can be, for example, in HTML, they can be in JSON, and you may start with data in one format and have to transform it into a different format in order to push it into another application. The third format that you will encounter quite frequently is CSV, comma separated values, and that basically looks like a spreadsheet with rows and columns. So it's a much more limited data structure than what we see here. This one can handle trees. A CSV structure can only handle rows of data. But when you're dealing with databases, you're ultimately wanting to get into that something that looks like a table in order to store it into a relational database. Okay, so back to the program. Let's see, where did I start this program? Okay, I have it in upload tests. All right. So if you have all of the libraries that you need, and you already, if you have this program, macallan.html, to verify that you do have it correctly, from the command line, wherever you have this program stored, you can say Python, and then macallan.html.py, and this should run the program, and there we are. You can see all of the data. Let's go to the beginning if we can. As you can see, this is quite it's a huge structure. And this is still part of it. And so here's all of the warnings that the parser sent out that says, hey, I have a starting tag that I can't find an ending tag, or I have an ending tag where I didn't expect one. And it tells you what line you can look at in the original HTML source to see what it is that's going on. But once it did that,
can you show please again how to get the file, please?
which file?
The Macallan. Yeah.
Oh, there should be a USB key making the rounds.
It only had the HTML.
Only the HTML, yeah.
But you get it from the website, no? You open it in a debugger?
No, it only had the HTML tree. That's the only one that it needs, because the rest of it should be libraries that are installed in Python. So if you...
I think he wants to know about the Macallan one.
Yeah, oh, I didn't give you that one?
I don't think so.
Oh, all right. Sorry. It's not a biggie. If you guys want to try to write it, let's see. I have to tell you a little bit about this. This.
How about creating a gist? G-I-S-T?
Yes.
On GitHub?
How do I do that? This, I want to show you this at line 8 and 9 and then 10 through 15. This is a technique that you use in Python when you want to include in your Python path code that is in a different directory.
What is this called? Macallan?
Macallan, yeah. HTML.py.
There you go. You can download that McAllen HTML file by going to that URL there. It'll open up the this gist, and what you need to do is click on raw, and then you download the file by saving it. And there it is, so you can do that. Cool.
All right.
And then, did you just want to say something about the file? Well, I guess you can until.
Yeah. Let me know when you guys have a hold of that macallan.py. You have it? You're done?
So it should be a new window, right? This one, the McAllen is.
Yeah, just on your browser, go to https://goo.gl/QNR5SM, and that will bring up the code. All right.
So once we download,
Where we put it?
yeah.
Put it in any directory. Put it right next to the HTML tree.py.
So we create another window with Python.
Yes. Now there's now it's actually yes. You may need to hack into this. You may need to hack into this program to get it to work for you. Here's what's happening. The way this program is constructed is that it expects some sibling directories to contain additional code. And right now it's expecting to be, says, I expect to be in the upload test directory. And next to the upload text directory, there's the utilities directory. And from it, I want to pull this particular program. And this all has to do with dealing with large libraries in Python where you have the code separated into different bits and pieces. But in your case, you can put the HTML tree file right next to the McAllen file. And then what you need to do, if you do that, is just, instead of from utilities, you just say import HTML tree. When you say import and you give it a particular module name, it looks in the same directory where you're currently working for that Python module. In my case, I had it in a different directory, so I had to go tell it there's a Python package called utilities, here's where it is, go look for the program there. You guys, is this making sense to you guys? Yes. Python has a concept. Python has a concept of modules. You can see these, everything that you see with this little box next to it, that's a package, a Python package. And inside that Python package, then you have the different modules. Yes?
Oh no, that's just for assistance.
Okay. And what makes it a Python package is if you look in each and every one of these, there's a particular program or a particular file called init.py. And that init.py tells Python this is a package. And what is contained in it is Python programs. So Python knows how to navigate those packages to go find stuff. So I have a package called utilities, which is where the HTML tree program is stored. And then the program that I was running is in this other package called upload tests, and that's where the Macallan HTML.py is. So Macallan HTML.py needs to pull in some code that's in the utilities package. And in order to do that, we perform this magic here that says, I want to add to my Python path whatever libraries or whatever packages you can find at my parent directory. So this code here, which you guys don't really need, it says go up to the parent directory, which is PyShared, and then look for any packages underneath that directory, which includes this utilities package. And once I do that, once I add that to the path, then I say, okay, now look for the package called utilities and go import the HTML3 module from it. In your case, HTML3 is in the same directory as the Macallan HTML.py, so you don't need to say go to this package to grab the code. You just say import HTML3 and you're done. Yes?
Are you using a framework, or are you just you have in your mind where you're going to put all these files like utilities, and is there any framework for Python?
There are several. This is a pretty hacky one when it comes to it. Normally, when you have a library in Python, you create what's called a Python egg, and it's an installable module that then goes into wherever Python stores its utilities and its packages and so on and so forth. And once you do that, you don't have to do any of this. And things work a lot better. When you do a pip install, that's essentially what you're doing, is you're grabbing things and you're putting them in the conventional places where they're supposed to go. Because in my working environment, in my company, Python is kind of everybody has their own version and their own conventions. We're not allowed to install these modules into the common area where it might interfere with someone else's project. So we have to be very circumspect in the way we organize things. So that's what's happening here. We have this set of modules that are only available in my project, and within it, in order to navigate, we use this technique that says wherever I am, go up one directory, and whatever packages you find there, use them. And it's basically very simple. It's the way it works is the first thing you do is you find what's my parent directory, and that's what this line does. It uses the OS module. It says give me the path, give me the absolute path of wherever I am. That underscore underscore file underscore underscore, that in Python gets translated into whatever this program is. This program that you're executing right now, I want to know what its name is. That gets passed, converted into a path name, and then we pull out its parent, and that's what we store in parent directory. So if I put a breakpoint there, and go back into the debugger, and I run it. So we're there. So first, let's do a little bit of deconstruction here. Let's see what happens. There is another part of PyDev, the Eclipse actually, in the PyDev plugin that allows you to construct Python expressions and evaluate them while you're running the debugger. So we can take advantage of that to explore what this line is doing. So underscore underscore file underscore underscore is this users gquiñones Pythia Python source upload test Macallan HTML.py. So it's the name, the absolute path of the program that I am currently executing. That gets stored in a variable called double underscore file double underscore. And then we're using the OS library. Excuse me. And says, give me the directory name of this file. And that gives us this, without Macallan HTML.py. So far, so good. And now we ask for this other variable, OS path parent directory. Let's see what that is. So the path directory is up one level, one directory level. So this OS path directory is a variable that has a different string depending on what operating system you happen to be running on. And the operating system that we're running on, up one level is expressed by 2 dots. In other operating systems, it may be something else. So in order for this program to execute in Windows or in Linux or in whatever environment, and I use this special variable so that Python itself takes care of giving me the proper notation for that, for what the parent directory is. So then I'm saying join to it this parent directory. So that gives me a syntax error. There's some missing. There we go. So what it did is it took the parent directory of the program, which is upload test, and said go up one level from there. And then finally I say, whatever that directory is, now give me the absolute path. Take this users gquiñones Pythia Python source upload test ... and convert it into an absolute path. And that finally gives me this. So essentially, we just went up 2 levels from where the program is executing, which is Python source. So that's our parent directory. And then what we're going to do is we're going to append parent directory to our syspath. Syspath is the list of all of the paths where Python is going to go look for modules. And it's going to add one more to it. It says, this source directory put that also in your path. And if you're looking for any Python packages, look for packages there. So that includes this utilities package. And then finally, once we do that, we can say, from the utilities, import the HTML tree. Does that make sense? Complicated. All right.
Alright, got one person that got it. Alright, I know how to do it now.
You got it to execute?
Yeah.
Very good.
Instead of doing from utilities, I just went ahead and did import HTML tree.
Exactly.
Rather than, yeah.
Yes. You don't need
And then the other thing is, if you're using 3.4 Python, I downgrade to 2.7. So I'm gonna go around and have them use 2.7 instead.
All right.
Let me switch with you, so that we can get him going too.
So, what time is it? 9:44. Is this a good time to,
8:44.
8:40? Sorry, I'm in Boston time always. Is this a good time to break the pizza?
Yeah, well, we get these going.
All right. So let's do that. Take 5, take 10.
Es una versión más ampliada.
Sí, creo que está.
Está rápido el internet. El internet está bueno. Este es malo. Oye, no entendí el paso de para.
And it does that on 90 servers simultaneously and generates about 1.4 billion rows per day, every day. It loads around 1.4 terabytes worth of data per day. So I'm going to show you some of this code to give you some flavor of some of the techniques that you might use when you're doing data transforms. And if you guys are interested at a later time, I can pull out some of this code and walk through it with you guys in more detail and that you have some samples of the code. But in general, this application, unless you have the data, the code is useless. So I'm gonna show you that. I'm going to close this by share it, and we're going to go to the system. The system's called Rainman. And I'm going to load the parser. And I'm going to load something called the metric schemas. So this parser is reading data in JSON format, and then it's looking for certain data in it. And when it encounters it, it's going to operate on that data. So in order to do that, I specify in this schema using this is just a Python data structure. Okay? this is what's called a map. This is a key, and these are values. Parentheses represent something that in Python is called a tuple or an n tuple. Think of it as a list, but it's an immutable list. You cannot change the contents of the list once you create it. You can only throw it away and create a new one. If you use square brackets, that's a regular list where you can insert and you can remove stuff and so on and so forth. So this is a hash map that says whenever you're looking for an account, map that field to something called account and execute this program on it. So this is one of the beautiful things about Python, that functions, once you create them, you can create a variable and set it equal to that function. And what that does is it doesn't execute the function and then return the value. No, it stores the function itself as the data element, so that from then on you can use that variable as if it was the function. So what I'm doing here is I'm creating a map that says whenever you encounter this particular field, I want you to apply this function, take that this toString function, and apply it to whatever data it is that you're looking at. For this one, this client time, I want you to convert it to a long. And I'll show you what these functions are. They're not trivial functions. And then this one toString2, and this has to do with, well, in this particular case, destination. Destination is a URL. And URLs are nasty things to try to deal with. They can be encoded, they can be unencoded, they can have all sorts of weird values, they can have control characters, they can have encoded control characters so that you look at it and it looks pretty innocent, but then you decode it and all of a sudden you've converted this into control characters, and when you try to operate on it, it just blows sky high. So in my parser, instead of putting a long set of case statements that says if the data is account, do this, if it's this other thing, do that. Instead of that, I created this field map that says here are the field names, and when you encounter them, map them to these other field names. This is a function that does a conversion, and if you have an error, replace it with this value. In this case, we're saying just return a null if you're unable to operate on that data. And you can see all of the fields that we're looking for. It says, if you find this field, throw it away. So none here says, whenever you encounter these fields, we don't care about them, throw them away. Don't waste any time, because, I mean, this data keeps 90 servers busy 24/7 just to keep up with the traffic. So anytime we can spare a couple of milliseconds of processing, we take it, so that we don't need more servers than we absolutely have to. And then the other thing, okay, so I'm not gonna get too much into this, but our schema changes. As time goes by, we need to process some additional fields. We can't just modify this thing and push it out to production in the middle of the day, because once we create a table in BigQuery that has a certain set of attributes, if you try to change the set of attributes that you're loading into that table, it'll blow up. So we have to wait until the day rollover, and then when the day rolls over, then we can create a new schema, and from then on, use a different schema. So what happened here is on August 15th, we decided to make a change. So we deployed it with a conditional date here that says from 8/15 forward, make these modifications to the schema. So prior to that, prior to 8/15, we deploy it. It continues to use the old schema. When 8/15 rolls around, boom, we now have a new schema. And then here's another structure. This is the description of how the fields are going to look like when they are in BigQuery. So in BigQuery, that account is defined by this map that says the name is account and the type is string. Or this one, well, all of these are strings. Here's a floating point number, and so on and so forth. So we define these fields, all of these fields, and then here we say, here are the fields that you're going to construct. We create a list, and here's each and every one of those fields. This gets converted into a BigQuery schema. So when 815 rolls around, create a new table, and we say, here's the schema that we want. This is the list that defines it. Well, that one was prior to 815, and as of 815, here's the new one. So what do we do with that? Here's the parser. We're going to walk through it in the debugger and give you a general feel of what's going on with these things. I'm going to put a breakpoint there, and we're going to parse through some sample data. So we're running the parser on my local machine. It's not connected to any of the servers or anything, but here's where we start processing the data. We extracted it into something called a line. And this line, I'll show you what a line looks like. This is our input. As you can see, this is JSON. This string. Post is metric.breakup.com, accept is that, accept encoding is that. It's just a field attribute value pairs after one after the other. So that's a line. When the parser operates on it, we submit the line. The first thing that it's going to do is, look, it's going to call the simple JSON. This is the same as the JSON library. This is a simpler. Simple means faster. That's all you need to know. We're going to load that line into this entry dictionary. So remember what the line looks like? Now we're going to, excuse me, we're going to, there we go. Now the JSON parser parsed that JSON string and converted it into a Python structure called entry dictionary. And here's what that entry dictionary looks like. Here's all of the fields. Accept encoding, accept language. This is all the data that is coming into the metrics collectors. The account, what time it was on the clock of the client, wherever that browser was. Versus our own time, when did our servers receive that data. Domain, what the event was. This was a video engagement. What does that mean? It means that someone watched video for X amount of time. They were engaged. Their eyes were on the video. What flash version they had installed in their browser. What host collected the information, what the local IP was, and so on and so forth. All sorts of details for that particular event. And then we check, make sure that it's not empty, so we have it. Okay, so the first thing we're going to do is we're going to pull the platform. We want to see what kind of player sent out this event. So we pull platform out, and it's an AS3 platform, meaning that it's a Flash player. You know,
You guys are familiar with Flash? All right. This particular player plays Flash video. There's an HTML5, and there's other players, and so on and so forth. But if it's an HTML5, we're going to do some additional operation. We say, our HTML5 player is only there to support mobile devices. If you try to run it on a regular browser, it blows up. It's not supposed to, but our publishers from time to time make mistakes, and they deploy onto the desktop browsers the HTML5 player, which blows up and generates thousands and thousands of errors, and it floods our collectors. So if they're running the HTML5 player on a desktop, we want to throw it away. So we check, is it an HTML5 player? Nope. All right, so now that we're satisfied that it's not an HTML5 player, we're going to now extract the data from that entry dictionary that I showed you. And that's done here in this select entries. And this is where we're going to use that structure that I showed you before. So first thing we do is we extract the entries. I'm hitting the F5 key and walking into the particular function. So we're in the extract entries function. And the first thing we want to do is decide, is this an event we want to keep, or is this an event we want to throw out? And to do that, we look at another structure called an event map, and we say get the event type and go to the event map, and from there extract the function that's going to examine the data and tell us whether we want to keep the data or not. Okay? So this is a lookup table of functions called event map. Let me show it to you. It says, if it's a video engagement event, run the analyze engagement event function. If it's US data, discard it. If it's analyze player load event, if it's a player load, analyze the player load to see if we want to keep it. If it's a data load, discard it. Okay? So
on the previous one, so yeah, that one you put the like if it's video engagement, you on the other side you put the function that it will go. Okay.
yes.
Okay.
All right. So event map is a hash key value pair.
Okay.
But this, the value that is stored in there is a function. not a.
Yeah, if it's that, call that. Okay.
Yes. So this is where it gets cool. All right. So we're saying go to that map and pull the function for whatever event it is that we're operating on. So now discard event test is an instance of some function. We don't know what it is at this point in time, but we know that it's a function that we want to apply. So if this is not a null value, because remember, if we say get whatever for event, an event happens to be some garbage value, and go to the map, to the hash map, and it's going to come back empty because it's not one of the possible values. So anything that's not on the list returns a null. So we have to check, well, is the discard event test null? If it's not null, then execute the function and pass it the entry dictionary. So here, the function that we just got, we're going to execute. And here is where, what happened? So it's analyze engagement event. So it was an engagement event. So the function that got executed is this analyze engagement event. So now we're inside that function to determine, do we want to keep this engagement? You see? So this is one of the nice things that you can do with Python is you can create these hash tables that says for these values perform these operations, and you can stick the functions in there, and instead of having these complicated these case statements or if then else statements, you just say go to this hash map and pull out the appropriate function to perform it, and then perform the function.
With that value, right?
Yep.
Oh.
With the value, whatever value you want to pass it, but essentially you go to the hash map, and what returns from the hash map is the function that you want to execute, whatever that may be.
And Python is the only one that has that ability to do it?
No, it's not the only one, but it's one of the features of, what do they call them? They call them duck languages. So you can put it, first of all, functions are what are called first class members. Functions have the same rights and privileges as any other data object that you have. That's one of them. And the other thing is that you can execute the function as long as whatever function it is, you know what parameters you can legally pass to it. So it's a type of polymorphism, which is a feature of object-oriented languages. But this is polymorphism on steroids, because you just saw that without knowing what the function was at the time, I pulled it and I executed it. And I just passed it the entry dictionary. So what it means is whatever function I execute at that point better allow one argument in, and it better be something that is consistent with what we expect to see. So the analyze engagement event expects a dictionary, which is another hash function, hash table. Okay. So where are we? We're here. We pulled out the platform. Again, it's an AS3 platform. And now we're going to check. Is it a Video.js, AS3, iOS native SDK? If it's any one of these guys, return false. False means don't throw it away. Because the question we're asking when we call this function is, shall I throw this event away or not? So false means don't throw it away. True means yes, throw it away. So in this case, we're going to see that we're going to return false. So when we return, it says if the start event test is false, so we're going to skip what we would have done there, which is to increment the number of skip records and return. So now we're going to continue processing. Next thing we're going to do is go back to the entry dictionary and get the remote IP of whatever desktop or mobile device actually sent out this event. Somewhere out there in the world, someone watched 10 seconds of video. Now we're going to find out where they are. Okay? So we get the remote IP, and we do a little bit of cleanup, and then we get the time. Now we're going to call this function whois. This function is a library that we pull in that is going to tell us who this person is that owns this IP address. So let's see who it is in this particular case. Oops. F6. All right, so data. What is it? No, it's not. Yeah, who owns this IP address is who is the internet service provider. And in this case is Bezek International.
And based on that, you can tell the page.
Well, no, that's where the where is function comes in. So now we're going to find out where it is. And then the data says, All right. So Asia, country code IL is Israel. And what the latitude and longitude is of the of that particular source, and so on and so forth, and what their time zone is. All right. Well, you get the picture of how this is operating. We're going to go through each and every one of these fields and say, oh, this is a longitude, so convert it to float. This is a URL. Be careful with it. Do a decoding, strip out any control characters, whatever else, and then return a string that is a regular 8-bit ASCII.
What kind of industry or companies needs these services, and the purpose why?
The purpose is to verify that our players are playing videos correctly and that they're delivering whatever content it is that our publishers want to publish. One of our customers, for example, is Azubu. Azubu does live streaming of video games. And so every day you can, in fact, So here's where our traffic is coming from. This is updated. This is, each one of these represents 1 minute of real time. And we're normally between 20 and 20 minutes behind real time. It says that most of our traffic is coming from the US, followed by Australia, then Canada, Great Britain, and the Philippines. Okay, that's one of the things we derive from here. What are the browsers that they're using? Embassy is a collection of browsers. It's a media source extension. Chrome is one of them. It's the next generation that's coming browser features, so we track it. But here's Chrome version 44. And look, Chrome version 45. What you can see here, and this is really interesting, is that Chrome version 45, you see in red, is going up, and version 44 is going down as people are updating their browsers.
Yes, how many hours per? Yeah, how many hours video is watched per hour?
I can tell you how many here. See that green line total?
Okay.
This is 1.4 weeks of video per minute.
Per minute. Okay.
1.4 weeks per minute. And this is just one of our platforms. This is what's called the Brightcode Player, which is our latest one that is just coming online. The AS3 player is 4 weeks of video watch per minute, every month.
How many years per hour?
No, like seriously,
Yeah.
because you're gonna get on, if you get, how many weeks?
4 weeks
4 weeks
per minute.
per minute?
Per minute.
Just 52, no, sorry, it will be 52 divided by 4. On that you will get, on that many of minutes, you will get a year of data being transmitted.
Mm-hmm. About a year's worth of video per hour. More than a year's worth of video per hour.
Well, that's a lot.
And then we say we're wasting our time.
All right. So, did that answer your question?
Yeah, a lot.
Here's the other thing we're interested in, and this is primarily this is errors. What types of errors we're seeing from the field, and you can see these jumps when there's a particular incident that occurred. Normally what it is one of our publishers, and a big publisher, made a boo-boo when they deployed a particular player and it's not working properly, so it's sending errors out the wazoo. We detect it, we investigate, we contact the customer and say, excuse me, sir, but you need to, right now nobody's watching your videos, and you need to fix your player. Okay? And this is measured. We don't count the number of events that occur, but the number of sessions, number of active users that experience some error on any given minute. So there were 2,599 sessions throughout the world on that particular minute that reported some error. Okay?
And you just go with the transmitter and have him to fix it?
Well, it depends on just how severe the situation is. Normally, these are global statistics, but we also provide dashboards to our customers so that they can see their own traffic. They can't see anybody else's but their own. And they can see if they just deployed a player and their traffic drops. Oh my God, what happened? Those kinds of things. You can see here, for example, there's a big jump in errors around 4 p.m. to 8 p.m. I've already investigated this. This is Indonesia. There's a particular customer that of ours that is in Indonesia, which becomes very active that particular period of time. Probably some soap opera or something that is very popular, but a lot of the machines that are deployed in Indonesia are Windows XP machines running Firefox, and for some reason they get a lot of errors. And you see it here. You can see the particular, these are the IDs of the customer that are experiencing the most number of errors. And from there we can go contact them. But you can see it by country. See the blue, Asia, Indonesia. So of all of the errors that we saw, the bulk of them were coming from Indonesia.
And you can identify like the very first computer where the problem was reported?
We can identify whether it was a desktop or mobile, what browser they were using, what player they were using, whether it's an AS3 player or an HTML player or a video.js player.
Sí, strings. Es la hora, entonces vas por el primero que ocurrió y ves en qué ocurrió.
Yep. And you can see right here, see that same jump? Fox. Same jump. The yellow is Windows 7, blue is Windows XP. Yes, it's still out there, and we have to support it.
Wow.
All right.
You don't see any Windows 10 over there? No?
Not yet. There's probably, we're not showing all of the operating systems. We're only showing the top 5 in terms of traffic. So Windows 10 would have to come up significantly in order for us to show it on this graph. We only collect data on the top 10 and we only show the top 5. Anyway, that's what data transformation is all about. You get these JSON events coming in to collectors, you're parsing it, you're converting it into CSV files, you're uploading them into this massive database. Then from there, you're summarizing it and pushing it into a graphite database, which is this.
Wow. Yeah.
All right?
Yes.
Any questions?
I remember my questions.
All right. We're done then.
Well,
Thank you very much.